Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about area under a curve using limits of sums.
Minute Math, when you need help you use Minute Math.
We're given this problem right here. F of x is equal to 3x plus 3 on the interval from 0 to 3, and we want to find the area under the curve using the given interval, and we have to use the limit as n goes to infinity of the upper sum. Well, since our function is increasing always, and specifically on our interval, our upper sum is going to be like the right endpoint. Okay, we're using there, the right endpoint. So we kind of have to set up our limit here. Now, I have the limit here as n goes to infinity of the sum. We're summing up a whole bunch of these rectangles. K equals 1 to n. And this is where it gets tricky. Okay, I have to change my value of x to find what x value needs to be put into it. Because remember, we're finding the sum of each rectangle. It's kind of like a height times the width. And so the height of the rectangle is determined by the output here, and it's the right side of it. So I have 3 times, and I'll leave a space for what we have under input here. And then I have a plus a 3. Now we need to multiply this, so this right here is going to be the height of the rectangle. We have to multiply that by what's going to be the width of the rectangle. And the width of the rectangle determines on how many rectangles we have. So what we need to do is take our interval from 3 minus 0 over the number of rectangles we have, which is going to be the n here. And so this right here is my width, just so you can see it. So we have the height of the rectangle we're defined here, and we have the width as 3 minus 0 over n, which is going to be 3 over n. So what does the height need to be? We need to find the x value that plugs into that. Well, from here, we know we start at 0, okay? So we start at 0, we take our 0 value here, and we have to add the width to it, right? We add the width to that, right? Whatever our width is going to be, boom, that's the first right endpoint. So 0, so start here. First one here is a 3 minus a 0 over n, again that width. And then we have to multiply by the variable k to see for each one that we're doing. Okay? Right there. And now we set up our limit here. So now we have to go see if we can simplify this slightly and then evaluate the limit. So we have the limit here as n goes to infinity of n sum k equals 1 of this inside. How much should I simplify that out? Well, 3 minus 0 is 3 over n times k is this 3k, or 3 over n times k. So we have here a well, actually here, this becomes, so I save some space here because I think I'm going to need a lot of it. That's 3 over n, right? So 3 over n times that 3, and the k here, comes out to be a 9k over n plus 3, and we're multiplying that all by the width on the outside here. Okay? The width on the outside. I want to make sure I'm just make sure I have everything lined up here. Oh yeah, extra parenthesis, that's why. I was wondering, I was like, I know that needs to be on the outside. 3 over n, I forgot that extra parenthesis over the whole thing. Apologize. Okay, because that's the height times the width. Got it right here. So now let's keep simplifying this out. The limit as n approaches infinity, the sum from k equals 1 to n. And let's go multiply this 3 across the board here, where we can. Okay, so 3 times the 9k over n here. We have the 3 times the 9. Did I do this right? Yeah. Sorry, oh my goodness, I'm flipping things around. 3 times the 9k is a 27k over n squared. Plus 3 times 3 is a 9 over n. So I got flipped around because I actually flipped this around. Okay? So to simplify this out one more time, before we take the limit as n approaches, or the sums, I'm going to break this to be 2 different sums. And I'm going to reorder it and put the 9 over n first here. So to do that, I have the 9 over n, I'm going to put that one first, k equals 1 to n over 9 over n plus the sum k equals 1 over n of 27k over n squared. Okay. Now hopefully we have enough room here. I think we will. The limit again, as n approaches 0 of, we can pull out that 9 over n out front of our sum. So 9 over n here times the sum from k equals 1 over n. And what's left is just the 1. It looks like our definition. Same thing here, we're going to pull out the 27k. 27k here times the sum k equals 1 to n of just 1 over, oh, we pull out the n, not the k. See, I always do this. It's okay, we all make mistakes, right? Bear with me if you're one of the few viewers of this video. Pull out the n squared, so 1 over n squared, and we're left with the sum from k equals 1 to n of a 27k. Or pull out the 27 as well. See, once I get a little flustered, you mess up a little bit. It's okay. So 27, say up here, and we have a k. And that's also, I hate writing down low. Let's go simplify this up. Now, this limit is of everything, just so we know here. Okay, don't forget to take a limit. It's easier right up here. Limit as n approaches infinity here. Well, we have a 9 over n times the sum of 1 is just going to be an n. Plus, we have 27, if you can see it, over n squared, right there. And the sum of k comes out to be that n times an n plus 1 over a 2. And now we have to simplify all of this, okay? So we have the limit here as n approaches infinity. The n's cancel right here, and we have a 9. Plus, well, we have this n squared, cancels with that n here. And so we have a, if it's easier to see, we have 27 distributed across to both parts. 27 plus n plus a 27 over a n or a 2n right there, okay? Well then from here, okay, we can break this apart to two fractions again. So we have limit as n approaches infinity of 9 plus, well, 27n over 2n plus 27 over a 2n. We need to be able to take the limit, and the n's cancel here, and that's fantastic. So now we have the limit as n approaches infinity of 9 plus 27 over 2 plus 27 over 2n. And at this point, we can take the limit, because we have n just in the denominator as we go to infinity, and we know this will go to 0. So we're left with our constants, 9 plus 27 over 2, and 9 plus 27 over a 2 comes out to be a 45 over 2, which is equal to 22.5. So after all of that, and bear with me, sorry for the mistakes out here, but it's all good, we got there. Our final answer here is a 45 over 2. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.